everyone, welcome to SmartPM. This is unit number 7. Here we're going to review PERT and CPM. And the complexity of the schedule management knowledge area is often challenging to students, thus warranting this review. So we'll be looking at some of the tools and techniques that we saw under Develop Schedule. And we'll also then apply some of the advanced techniques using confidence levels in the duration estimates. Just by way of review, by now you should be familiar with the terms analogous estimating versus expert judgment and determine which is more appropriate given a scenario. Should also know about rolling wave planning, and you should also be able to sequence the processes within schedule management. Take a moment, pause the video, and review and ready. And here is that sequence: plan schedule management, define activities, sequence activities, estimate activity durations, and develop schedule. So turning now to develop schedule, we're going to focus now on some of the tools and techniques that we saw earlier and expand on them. Let's start with the critical path method, remembering that we had a network diagramming technique, and that's used to predict the total project duration. Critical path determines the earliest time in which a project can be complete, and it's determined by the longest path through the network diagram. Critical tasks which drive the completion date for this project, and that is where the risks are. If any of the activities on the critical path take longer than planned, the entire project will slip accordingly. I just want to emphasize once again that the use of the words earliest and longest. In that way, students won't use the word shortest, as it may be confused with the shortest time, shortest path. So we have a network diagram activity on node, which is the critical path. Pause the video and resume when ready. We exhaust all of the paths and determine that DEF is the critical path because it is the longest path and the earliest in which this project can be complete. We also remember that float is defined as the amount of time an activity can slip before the critical path changes. An activity on the critical path is zero float. And we can use the term slack and float interchangeably. Under network analysis, we've determined a number of characteristics of each activity, starting with the early start. The early finish can be computed using the forward pass calculation. Early start plus duration minus 1. We also have the late start, which could be computed using a backward pass, but we need the late finish. Late finish minus duration plus 1. Using the backward pass gives us the late start. The notation that we are asking students to remember, with the duration indicated in the middle and the characteristics in each of the quadrants. Float can be calculated using either the start dates or the finish dates. This is something that you want to commit to your brain dump. A comprehensive example in the Heldman text gives you an opportunity to compute the early finish and using the forward pass, and similarly the late start using a backward pass. Next tool and technique is resource optimization, and there are two techniques I wish to bring to your attention. And starting with resource leveling, think of resource leveling as a way in which we can adjust the start and finish dates based on the resource constraints. An example of this could be that we do not want our staff to exceed 8 hours per day with respect to their work, and therefore under resource leveling, we will actually extend the schedule. And note, in this case, we've extended the schedule by 2 weeks, from week 7 to week 9. The second optimization method is called resource smoothing. In this case, what we want to do is reallocate resources from non-critical path items where there is float and be able to provide a more optimum schedule by moving resources around. In this case, we've moved the resources using the float, and note that the scheduled date of completion is not changed. Leads and lags. We have a lag where we are directing a delay in the successor activity, whereas a lead allows for an acceleration of the successor activity. Best demonstrated in the base case, where we have two tasks, A and B. B cannot start until A is complete, a finish to start relationship. But if we wish to compress the schedule, we have some choices, either a lag or a lead. Under a lag scenario, we would establish a start to start relationship. So A will start, and in 2 days into its work, we will then start B. Under a lead, we'll establish a finish to start relationship, but in this case, A will start, and 2 days before it finishes, we'll commence with activity B. Leads and lags. Schedule compression. There are two techniques by way of crashing. I just remind students that think of crashing as where you're applying more, whether it's overtime, additional resources, maybe you're paying more to expedite from a supplier. In this case, you're crashing. Whereas fast tracking involves doing activities in parallel rather than doing them in sequence. Best illustrated with the chart below, where A, B, and C are activities that are typically done in sequence, and under a fast tracking scenario, we would choose to do B and C in parallel. In either case of a crash or a fast track scenario, there are some risk impacts, and these risk impacts could in fact backfire by causing extra cost, quality problems, rework, and therefore lead to even a longer schedule. Let's now look at crashing. Crashing example here, we have 4 activities, A, B, C, and D, and we're given some information with respect to the original duration versus crash and some cost-related information. Take a moment and look at this particular question, pause the video, and see if you can determine which of these activities you would choose to compress the schedule by 1 day. Pause the video and resume when ready. Here is the solution. First step, let's determine the extra cost. We've highlighted that. And let's also determine the time savings associated with that extra cost. And what we want to do is calculate the crash cost per day. So the extra cost of $2, time savings of 2 days, is crash cost per day for activity A. We do that for each of the activities. So if we wanted to compress the schedule by 1 day, we would ideally choose activity A because it has the least crash costs per day. Now let's turn to advancing some of the PERT principles. Earlier we did it with a single activity, but now we're going to apply the PERT technique to an entire project. Imagine for a moment we have 15 tasks in a network diagram. We have the information with respect to descriptions, predecessors, the optimistic, most likely, and pessimistic durations. We're going to now advance this PERT technique using a 4-step approach. Step 1, let's calculate the PERT for each of these activities using the PERT formula. Step 2, we're going to have to determine the critical path. Ordinarily, we would have to create the network diagram, but assume for a moment the grayed areas you see in this chart represent the critical path. In this case, 1, 5, 7, 8, 12, 14, and 15. For those items on the critical path, let's turn to step 3. We're going to calculate the sigma. We're going to square the sigma for those critical path activities, and then we're going to sum up the PERT, the sigma squared, and the sigma. In this case, the PERT is 114. The sum of the critical path sigma squared is 49, and we square root that value of 7. Step 4, we can begin to make the probability predictions. Using the information that we've previously calculated and using the confidence levels that we've used earlier, we can now make some predictions. A 68% confidence level means that 114 days plus or minus 1 sigma, we can say that this project at a 68% confidence level will not exceed 121 days. At the extreme, at 99.9%, 114 days plus or minus 6 sigma, meaning that this project will not exceed 156 days. So now the project management information system, we'll see this repeatedly as a tool. Let's make sure we understand what it means. It consists of any tool and technique to gather, integrate, disseminate project management processes, any information that we can use to analyze, to report. We can use that tool to support all aspects of project management, right through the life cycle of a project from initiating through to closing. And it doesn't necessarily have to be an automated system. It could be a manual system. Some of the things that we would like to do by way of features include a WBS creation, scheduling, earned value management, which we'll discuss when we get to costing, charting, critical path, variance tracking, resource tracking, leveling, and any form of project reporting. And some examples of a project management information system include MS Project, other products such as Project Scheduler, Wellcom, and Primavera. Some of these you may already have experience in. So in this particular unit, we've reviewed the tools and techniques of develop schedule, and then we've also applied some of these techniques of confidence levels and duration estimates, and you'll have an opportunity to test yourself in the advanced concepts with the assignment in this particular unit under duration estimating. Let's now look at some exam questions, starting with critical path, just to make sure that you are fully understanding how this works. Critical path, take a moment, look at this question, pause the video and resume when ready. Correct answer is B, ADEH, 34 days. Next question. Pause the video and resume when ready. Correct answer is D, AFGEH, 36 days. Next question. Take a moment, pause the video, and resume when ready. And using that notation, we've determined that the missing quadrant is early finish with a value of 14, duration of 4, a float of 6. Next question, pause video and resume when ready. In this case, the missing quadrant is early finish, value of 17, duration of 4, a float of 12. And you recall we looked at this question in the previous unit to explore the notion of negative float. Negative float is where the critical path exceeds the target, in this case what management wants. So take a moment in this question, pause the video and resume when ready. -3 days, the correct answer is B. Again, emphasizing negative float. Next question. Pause the video and resume when ready. And here's the solution. We first draw the network diagram as shown below. We exhaust all of the paths. We've determined that the longest path is 4 and 5 to end. Therefore, that's the critical path. Since task 5 lies on the critical path, there is no slack or float. Therefore, the correct answer is choice A. And here's another PERT problem. Take a moment, pause the video, and resume when ready. I've given you a blank sheet in which to compute the confidence levels and also given you the solution. And check your answer accordingly. Next question, we have a change in the critical path. Pause video and resume when ready. Correct answer is D, AFGEH, 36 days. Next question. Pause the video and resume when ready. Here is that solution. We exhaust all of the paths. Choice is A is the correct answer. Next question. Pause the video and resume when ready. And here is that solution. Step 1, calculate all the paths, make the determination of the critical path. Step 2, identify the paths that have activity D. We've determined there are 2 paths of 14 and 12 days respectively. Step 3, subtract the path sums from the critical path of 19 and choose the smallest one. Therefore, the answer is C, 5 days. Next question. Pause the video and resume when ready. This is a trick question. You're told that A, B, and C are not part of the critical path. That should alert you to the fact that you cannot then calculate the duration for the project. So D is the correct answer.
Next question. Pause the video and resume when ready. In order to successfully answer this question, we need to first draw the network diagram. We exhaust all of the paths to determine the length of each path. We determine which is the critical path. Since the longest path through this network diagram is start 4-5, this is the critical path. We note that task 3 does not lay on the critical path, therefore there must be float. To calculate the float, we take the critical path duration of 12, subtract the duration of the path having task 3. The difference is 1. The answer is B.
Next question. Pause the video and resume when ready. Here's a blank worksheet for you to compute the solution. And here is that solution. Pause the video and just check your answer. Choice is B. And that's it for unit number 7. Just by way of the unit schedule, we've completed the CPM PERT review. There is a benchmark test, quiz number 5, and a series of assignments that you'll find in both the Heldman text as well as in your notes, a CPM assignment and a crossword puzzle on time. As we look to unit number 8, we have a number of new processes which we're going to be exploring: cost, quality, resources, communications, and procurement. Good luck with that reading assignment, and we'll see you at unit number 8.